Coal in its basic form is not suitable for direct use in the blast furnace burden. It must therefore be converted to coke. A mixture of iron ore fines, recycled ferriferous products and fluxes is baked on a slowly moving strand with coke breeze and anthracite being used as fuel. This produces sinter, a porous substance forming an ideal raw material for the blast furnaces. Once in the form of sinter, the iron ore is ready for the blast furnaces. Air, heated to 1250 degrees, is blasted into the tuyere. This converts the coke and pulverized coal into a reduction gas, carbon monoxide. At the same time, this process generates the heat necessary for melting the ore. The conversion from ore into hot metal takes place as the blast furnace burden is coming down. The liquid and carbon-rich hot metal is collected in the heart of the blast furnace, where it's tapped and runs into torpedo ladles. Each torpedo ladle can carry about 200 tons of liquid hot metal to the steel shop. If necessary, the hot metal is first desulfurized. Subsequently, the torpedo ladle is emptied into the hot metal ladle. A crane takes this ladle to the slag removal station. Afterwards, the hot metal is charged into the tilted BOF vessel. Together with the hot metal, a precisely weighed quantity of scrap is loaded into the BOF vessel. Adding scrap is necessary because it has a cooling effect on the converter process. 15 to 20% of the raw materials necessary for steel production are replaced by recycled scrap. A water-cooled lance is used to blow pure oxygen on top of the hot metal bath. This oxidizes the carbon and the impurities from the metal bath. Hot metal has now become liquid steel. In order to optimize this refining process, various fluxes are added to the bath, and an inert gas is injected via the bottom plate of the BOF vessel in order to obtain an optimal mixture. In order to optimize the steel quality, it's further purified in the steel ladle treatment station. A stirring lance blows argon deep down in the steel mixture. Steel grades with an extra low carbon content or special alloys are treated in a vacuum degassing installation. In the two continuous casting lines, the casting crane transports the full steel ladle to the turret. The steel flows into the tun dish, which can contain 80 tons of steel. From the tun dish, it flows into two water-cooled molds, where it emerges as two endlessly solidifying strands. The cast steel solidifies as it's cooled by large amounts of water. The vertically cast strand of steel is now curved away so that it lies horizontally on the roller table. In a subsequent stage, these slabs are rolled into thin steel sheet. Therefore, they're first heated in walking beam furnaces to a temperature of typically 1240 degrees. The layer of scale built up on the slab surface is removed by a high-pressure water jet in a so-called scale breaker. In 2 roughing mills and 1 finishing mill, the 10-metre-long and 22-centimetre thick steel slab is then reduced to a steel sheet several hundreds of metres in length with a thickness of between 13 and 1.25 millimetres. As soon as it leaves the finishing mill, the strip's thickness, width, profile, flatness and temperature are measured. The finished strip is cooled by a series of powerful water jets in such a way that the strip reaches the coilers at the scheduled temperature range. Each coil is automatically strapped, weighed and given an identification number by means of a robot. Steel is a state-of-the-art, highly functional, and in many ways essential element of today's world. It's used in a wide variety of sectors, such as the automotive sector, construction, packaging, the sanitary sector, domestic audio and video appliances, and the machine construction sector.